Let's go to page 555, and this is lesson 12-2. The objective of this lesson is to define trigonometric functions of acute angles. So if you look on page 555, okay, you have the x-axis and you have the y-axis, and you have this triangle right over here. And this point is a point and just label xy. So xy just the coordinates. And here's your angle theta. Okay. Now over here, this is the adjacent side. Adjacent means it's next to it. Okay. So this is next to the angle, and this is the opposite side. So this is facing that. And the side that's slanted is called a hypotenuse. Okay. Also, you notice that this is the y, and this is the x. And if you were to draw the circle, this would be the r. Okay. So make sure you know all these. Now the definition of the function, so sine, so S-I-N-E, abbreviation is I-N. So this is sine of angle theta is equal to y over r, or equal to opposite over hypotenuse. Okay, and the cosine, or the cosine is a cofunction of sine. Okay, the abbreviation is COS. Okay, so these are the ratios. Okay, and this will equal to x over r, and this will equal to adjacent over hypotenuse. So these are things that you need to memorize. You need to commit this to heart. Okay, and tangent. Okay, abbreviation is TAN. This is equal to y over x. Okay, so this would be equal to opposite over adjacent. And so you need to know how to go ahead and make sure you can memorize all these. And you want to come up, different ways of memorizing this. So one way is using the acronym. So this would be S-O-H, so, and this would be C-A-H, so ka T-O-A. So ka toa, that's one way to memorize it. Okay? And so you want to come up with a way that it help you to, can come any way you help you to memorize it. Okay, the way I memorize it is I look at, so what I did is, the way I memorize it, think of this as like a stop sign. Okay, so this is a stop sign. And they kind of rhyme with, kind of synonymous with sign. Okay, so it helped me to remember sign is like stop sign is going vertical, and so by process elimination, the cosine would be the horizontal. So again, you want to come up a way to help you to memorize it. Okay, so this are the basic definition of the primary trigonometric function. Okay, also remember that tangent theta is also the slope. Okay, so this is equal to the same. This is same as a slope. Okay, so slope is the vertical over horizontal. Okay, so just be aware of that. Okay, and so this is, I kind of memorize it as this is a vertical, and this is a horizontal. Okay, I kind of just use that as my key to memorize it. So you can come up with a way to help you to memorize these definitions. Okay, okay, so let's go over example 1. Okay, so example 1, it says an acute angle theta is in the standard position. So again, standard position means it starts right over here, okay, and it passes through the point 4,5. Okay, so what you do is you just draw the triangle. So this is 4, so this point is 4, 5, right? So that means the x is 4, the y is 5. So this is the picture you have. Okay, so use your Pythagorean theorem to find out your hypotenuse. So a squared plus b squared equal to c squared. Okay, so a would be 4 squared plus 5 squared equal to c squared. So you got 16 plus 25 equal to c squared. So 41 equal to c squared. So c equal to square root of 41. So this length is square root of 41. And your angle theta is right over here. Okay? Okay, so you're looking for sine, cosine, and tangent. So sine theta would be, again, it's opposite over hypotenuse. So it would be 5 over square root of 41. Okay? And if you simplify these, you multiply, this will equal to 5 square root of 41 over 41. Okay? So you need to just go ahead and simplify that. Okay, now if you don't remember how to do this, remember you learned this from earlier chapter, right? So 5 over square root of 41, to get rid of the square root, you just multiply by the square root, right? And so this will equal to 5 square root of 41 over 41. Okay, that's where I get this from. Okay, cosine theta is equal to this over that, right? So it'd be equal to 4 over square root of 41. So again, you do the same thing, simplify, you get 4 square root of 41 over 41. Okay. And tangent theta, tangent is a slope is be y over x, so equal to 5 over 4. Okay. So that's how you do. That's how you find the function, the three primary functions. Okay. Now, so let's go to the next. This is called a secondary function. So on page 556, okay, you have other sets of functions. So you have sine theta is equal to the y over r, okay, or the opposite over hypotenuse, and cosine theta equal to x over r, and tangent theta equal to y over x. Okay, so again, those are the basic things. So these are this over here. So make sure you know that. Okay. Now you're going to get the other three secondary functions. Okay. So you're going to get something called cotangent. Cotangent, the abbreviation is COT. Okay. And cotangent would be just the reciprocal of tangent. So it'd be equal to x over y. Okay. And also equal to 1 over tangent. Okay, so it's reciprocal, so you just flip it upside down. Okay, and then you also have the secant. So secant abbreviation is SEC. Okay, and secant is the reciprocal of cosine. Okay, so equal to r over x, or equal to 1 over cosine. And cosecant, or CSC, so cosecant is a reciprocal of sine, so it would be r over y. Also, this is equal to 1 over sine. Okay. So they're just reciprocal. Now, normally, this is what you do. So whenever you're looking for trigonometric function, you just write sine, cosine, tangent. Then after that, you're going to go cosecant. Okay, and you're going to go. You want to get secant, and you're going to get cotangent. Okay, and so you find these three, and then after you just take the reciprocal to get these three. Okay. So you need to know which one go with which. Okay. Now, the way to remember is that each pair, you're going to have one regular function and you're going to have one cofunction. So this one has a co, right? CO, right? Cofunction, right? Then you will have no cofunction. This one has cofunction, so this will have no cofunction. So each pair, you're going to have one cofunction and one regular function. Okay? And tangent and cotangent have to go together, and therefore the other two just by using process elimination. So cosecant have to go with sine, and secant have to go with cosine. So again, each pair will have one regular function and one cofunction. Okay? So this is regular function and cofunction. Regular function, cofunction. And tangent and cotangent will go together. So cosine will have to go with secant, and sine have to go with cosecant. So if you can memorize these three, the other two is just reciprocal. And you have to know which one goes which. Okay? So again, these are basic definition that you need to know. Okay? So make sure you know these functions. Okay? So make sure you know your basic one. And after that, you just know which is the reciprocal of the primary function. Okay? So you got to know this right over here. I kind of like to. So again, these are different information, different ways of the definition. Depends what it's giving. Okay, depends what you use. Okay, but once you know the three, the other two is just reciprocal. Okay, so let's go over some examples. Okay, example 2 is to find the value of the sixth trigonometric function of an angle theta in standard position whose terminal side passes through 512. Okay, so you're looking for a point that passes through 512. So again, just you don't have to draw it exactly. So just kind of just guess. So it'd be 5 and 12, right? Now you can use Pythagorean theorem, or you can use your geometry, the spatial triangle. This is spatial triple, 5, 12, and this would be a 13. Okay, if you don't see that, okay, if you don't remember it from your geometry, you just use Pythagorean theorem. So you got 5 squared. Okay, so you got a squared plus b squared equal to c squared. So 5 squared plus 12 squared equal to c squared. So 25 plus 144 equal to c squared. So 169 equal to c squared. So c equal to 13. Okay, and here's your theta. Okay, so now to find sixth trigonometric function, so you start with sine. So sine is the vertical or opposite over hypotenuse would be 12 over 13. Okay, cosine is horizontal or the adjacent over hypotenuse, so it would be 5 over 13. So again, you have to know your definitions. Okay, and you got tangent theta. Tangent theta equal to opposite of adjacent would be 12 over 5. Okay, so after you get the 3 primary, you do the secondary. So you just take the reciprocal. So the one that go with sine is cosecant. So cosecant of theta would be 13 over 12. You just take the reciprocal, right? Just flip upside down. And cosine would go with secant. So secant of theta would be 13 over 5. And cotangent theta, cotangent theta would be equal to 5 over 12. Okay. And so that's it. So the key is to get your 3 primary, and the other 3 is just reciprocal. Okay. There are more in definition that you need to know the relationship between them. Okay. So on page 556, you also have another one that you see a lot is tangent of theta equal to sine theta over cosine theta. Okay, remember tangent is your slope, right? So this is basically what you're saying, the slope equal to the y over the x, okay? The difference in y over the x. Okay. So I'm going to put delta means the difference, so it means the height, the y over the x. Okay, delta means the difference, means the difference between the 2 points, that's the height. Okay, and the cotangent, theta just flip upside down, so you got cosine over sine. So this is more definition you need to know. Okay. Another very important identity is sine square theta plus cosine square theta equal to 1. Okay. So these are more definition that you need to know. So make sure you know these. Okay. Okay. So let's go to example 3. Okay, so it says find cosine theta. So you're looking for cosine theta. You can write down all your information and tangent theta. If it's an acute angle, okay, so if theta is an acute angle and sine theta equal to 1 over 3. Okay. Now there are many ways you can do this. Okay, the long way is you use Pythagorean theorem. You go sine square theta plus cosine square theta equal to 1, and you substitute. So you got 1/3 square plus cosine squared theta equal to 1. Okay? And so you got 1 over 9 plus cosine squared theta equal to 1. So you're minus 1/9 on each side. So you got cosine squared theta equal to 8 over 9. Then you take the square root. So cosine theta, and when you take the square root, you can just use the positive one. Okay? So this will equal to square root of 8 over square root of 9. So cosine theta equal to 2 square root of 2 over 3. Okay? So now to find tangent theta, so remember tangent theta equal to sine theta over cosine theta, right? So tangent theta equal to 1 over 3 over 2 square root of 2 over 3. Now to simplify complex fraction, you just multiply by the common denominator so that this will cancel out. So you got 1 over 2 square root of 2. And to simplify that, you need to multiply by square root of 2 over square root of 2. So tangent theta equal to square root of 2 over 4. Okay? Okay. So this is kind of a lot of writing, but in a similar way, what you want to do is, if you know your definition, okay? So what you do is on page 557, example 3. Okay, so when you got sine theta equal to 1 over 3, then what you do is, if you draw a generic triangle, sine is the opposite of a hypotenuse, right? So your picture would be 1 over 3 like that. Okay, and so if you use Pythagorean theorem, right? So here's your A. So I'm going to call this A. So you got A squared plus B squared equal to C squared, right? And so you got A squared plus 1 equal to 9. So A squared equal to 8. So A equal to square root of 8. So A equal to 2 square root of 2. Okay? So now, to find cosine is just this of this, right? So cosine theta equal to adjacent of a hypotenuse. So it would be 2 square root of 2 over 3. Right? And look, that's what we get, right? See that? The same answer, right? Okay. And tangent theta equal to this over this would be 1 over 2 square root of 2. So right away we jump from here to here already, right? See, that save you a lot of all this extra work, right? So this is much quicker to do if you understand the definitions, right? So if you remember sine is opposite of a hypotenuse. So use this definition. So break it up, right? Okay, and you multiply by square root of 2 square root of 2, right? So tangent theta equal to square root of 2 over 4. Okay, so this is a different way of doing the same problem. Okay, so it helps if you know your definition and use definition to draw your triangle, and it's much quicker than than doing this. Okay. Okay, so again, this is the solution 2. Okay, so this is the solution 1, and this is solution 2. Okay. Okay, now let's go to the next one, the complementary angle, page 557. Okay, so if you have the triangle, so here's your A, B, C. So the small a we're facing the big A, small b we're facing the big B, and small c we're facing the big C. So capital letters are angles, small letters, lowercase letters are for length. Okay? So this is there's another thing that you need to know. Okay. So now if you notice sine of angle A, so sine of this angle is equal to the opposite of a hypotenuse, would be A over C. Okay? And which notice if you have a cosine, if you have cosine of B, cosine of B means you look at this angle over here. So cosine of B is cosine, it would be adjacent of a hypotenuse. So equal to A over C. Okay, and notice that the same, right? Well, that's what this is. Co means complementary angle or cofunction of sine, right? Remember, COS means cosine, right? That means it's a cofunction of sine, means you're using the complementary angle, okay? So again, so cosine of B means using the complementary, so you use this angle of that, complementary of that, so you get the same answer, okay? So you got tangent A equal to A over B, and this will give you cotangent B, okay, same thing, so it'll be A over B. Okay, so that's what it is. So again, if you notice, so you got secant of A will equal to cosecant of B. Okay, so you got this equal to this equal to that. Okay, and vice versa. So you can just look at the table, just be aware of that. Okay, so now let's look at the other ones, the one in the gray box. So you also have sine theta equal to cosine of 90 degrees minus theta. Okay, and you got tangent theta equal to cotangent of 90 degrees minus theta. And you got secant theta equal to cosecant of 90 degrees minus theta. Okay, so what I'm saying is that, and you got the other one, so it's the same thing. It's vice versa. So you got cosine theta equal to sine of 90 degrees minus theta. And you got cotangent theta equal to tangent of 90 degrees minus theta. And you got cosecant theta equal to secant of 90 degrees minus theta. So what all this saying is that the sine of 30 degrees will equal to cosine of 60 degrees. Because they are complementary angles, right? And so you have the cofunction of it, okay? And vice versa. So if you have sine of 60 degrees, this will equal to cosine of 30 degrees. Okay, okay, because they are cofunction of each other. Okay? And same thing with tangent. So let's say if you have tangent, let's say you have tangent of 20 degrees. Okay, again, just use the example. Then this will equal to cotangent of 70 degrees. Okay, again, because they have to be complementary angles, so you get cofunctions. Okay, and vice versa. So if you had tangent of 70 degrees, this will equal to cotangent of 20 degrees. Okay, so that's what this is all talking about. Same thing. That's if you use like a secant of just any number, like 25 degrees. Okay, or let's use 45. Well, in this case, then cosecant also equal to 45, okay? Because again, they're complementary angles, right? You can just choose any random number. So that is cosecant of 30. Let's make it 40 degrees, okay? Then this will equal to secant of 50 degrees, okay? So you have to have the cofunction, and you also have the complementary angle, okay? So that's what this is talking about. Okay. Okay, now here comes the most important part. Okay, this is deal with the spatial triangles. So on page 55, page 58, so you got two spatial triangles. So this is your, let's redraw this. Okay, the first one is the 30-60 spatial triangle. And then you have the 45-45 triangle. And the relationship between is for 45-45 is 1, 1 square root of 2. Okay, and this is 1, 2 square root of 3. Now, where this came from is this is actually came from the equilateral triangle. See, this came from that. So if it's 2, this would be 1, right? This gives you 2, right? See that? 2, 2, 2, right? And you cut in half, and that's where you get this came from, okay? And this one is the same thing, okay? It came from a square, so you cut in half, right? And so it's, and use your Pythagorean theorem, right? 1, a squared plus b squared equal to c squared. This one you start with a 2, so 2, 2, 2, and you cut in half, you get 1 and 1, right? And so 1, 2, and use your Pythagorean theorem, you get that, okay? So in geometry, that's your most important thing you need to know, is your spatial triangles. And then from there, you can construct the table. Okay, so theta, so you got 30 degrees, 45 degrees, and 60 degrees. And you're going to get the sine theta, sine, cosine, tangent. And then, okay, so sine would be cosecant, cosine would be secant, and tangent would be cotangent. Okay, so this is the table. Okay, so you do the sine. So sine of 30 would be this over that, so it would be 1 over 2. Sine of 45 degrees would be this over this, and you simplify, you get square root of 2 over 2. Okay, so it's 1 over square root of 2, you simplify, you get that. Now 60 degrees, you have to use this angle, and so again, the sine is the opposite over hypotenuse, so it would be square root of 3 over 2. Okay? And cosine, if you remember, sine of 30 will equal to cosine of 60, right? And sine of 60 equal to cosine of 30. Okay, and sine of 45 will equal to cosine of 45. Okay, or you can just use a triangle again. So cosine of 30, cosine is adjacent over hypotenuse. That's that, right? And again, 45 degrees, right? Cosine is adjacent over hypotenuse. So 1 over square root of 2, you simplify, you get that. Okay? And cosine of 60 degrees, you have to turn this way. So cosine is the adjacent over hypotenuse, right? So it'd be 1 over 2. So you just have to turn, or you can either redraw the triangle or turn the triangle this way, right? Okay? Now tangent is the opposite over adjacent, so 1 over square root of 3, and you simplify that, you get square root of 3 over 3. Okay? And this one over here is 1 over 1, so give you 1. Okay, and the 60 degrees, okay, you turn it this way, so slope is this over this, so it'd be square root of 3 over 1. Okay? And so it'd be square root of 3. Now once you do that, now cosecant will be reciprocal of this, so this one, you take reciprocals, you get 2. This one, you get 2 over square root of 2, and you simplify, you get square root of 2. Okay? And this one, again, you turn it over, square root of 3 over 2, and you simplify, you get 2 square root of 3 over 2. Okay, you flip it over, and you simplify. Now the secant, you have to do this, right? So you flip it over, you simplify, you get 2 square root of 3 over 2. This one, you flip it over, and you simplify, you get square root of 2. Okay? This one, you flip it over, you get that. Okay, cotangent, this one, you flip it over, you simplify, you get square root of 3. This one, you flip it over, and this one, you flip it over, you got 1 over square root of 3, you simplify square root of 3 over 3. Another way you can do it is that use the tangent of 60 to get cotangent of 30, right? Remember that? Okay, so tangent of 60 equal to cotangent of 30. So that's, and tangent of 45 equal to cotangent of 45. And tangent of 30 equal to cotangent of 60, right? So you can do the same thing, right? Okay. So once you get this, right? Cosecant, okay, cosecant of 30 equal to secant of 60, right? Cosecant of 45 equal to secant of 45. And cosecant of 60 equal to secant of 30, right? So you got to know all the relations between them, okay? Okay, let's go to example 4. Use a diagram at the right. Find the length of the BC and side AB. Okay, so this is 30 degrees. This is A, B, C. Okay, and so you're looking for side BC. So that's this one here. And this one equal to 12. And you're looking for AB. Okay, So this is a spatial 30-60 spatial triangle. Okay. So this is the short leg, this is the long leg, this is the hypotenuse. So from long leg, see from short to long, you multiply by square root of 3. So see this one over here? So from short to long, you multiply by square root of 3. So this is like your starting number. So your short leg, okay, you multiply by 2, you double that to get the hypotenuse, times by square root of 3 to get a long leg. So now you have long leg, you have to go backward. Okay? So from long to short, you have to divide. Okay? So A equal to 12 divided by square root of 3. Okay, so again, you divide by square root of 3, so long divide by square root of 3 to get the short. And you simplify, so A equal to 12 square root of 3 over 3, so A equal to 4 square root of 3. Okay. So once you find the short leg, you just double that to find the C, right? So C will equal to double that because this is twice as that, right? Again, this came from equilateral triangle, right? You cut in half, right? So this is double that. So C will equal to 8 square root of 3. Okay. Okay, let's go to example 5. Okay, it's a diagram from the angle of A. So 3, 6. Okay, well this is twice as that. So again, if this is like your equilateral triangle, right? So this is like an equilateral triangle. So that means this would be 30 degrees and this would be 60 degrees. So angle A equal to 60 degrees, and that's it. So again, you got to know your spatial triangle. You must know this because trigonometry is measure of a triangle. So you use a lot of spatial triangles. So this is super important. Okay, so this is critical to know. So make sure you know your spatial triangles.